Well, good evening, everybody. Tonight I'm going to be speaking about some of the basics of solar thermal, and we're going to take you through some of the common system components and some of the common systems of solar thermal, so that hopefully you will have a basic concept of what it is, and you'll have a good understanding so that when you get an installer or you're going to do a system, that you will be able to ask the right type of questions to that installer. Okay. So the first part, what is solar thermal? Okay, so as Shane said, solar thermal is basically the heating up of a liquid as opposed to photovoltaics, which is the generation of electricity. The heated liquid is then used for various applications. You can store the heat, with piping, you can transfer it to different locations. It's very mobile once it's in that liquid state. Next slide. Today, how is it used? Potable hot water systems is generally referred to, you'll see, as the acronym SDHW. That's what we refer to it in the industry for the most part. Used for cool heating, radiant floor, space heating, commercial process heating, to some extent driveway, walkway, or bridge road melting. And we just came up with a new one last night from Jerry back there. Jerry's weed killing. He wants to start a new application with that next slide. The advantages of solar thermal. Materials are very advanced. The technology has been around for a long time. So this translates into a very efficient type of system. And the technology, because it's so advanced, is not likely to become obsolete anytime in the near future. It's very low cost per unit of energy that's produced. A typical 3 kilowatt system is about $8,000 installed. For that same energy with a photovoltaic system in kilowatts is about $25,000. Panel efficiency doesn't degrade over time like a PV panel will. And a solar domestic hot water system requires a lot less area for the panels because it requires a lot less panels to generate that same amount of energy. Most of the technology is fairly simple, which is good. I like simple. And the last thing is when you're replacing fossil fuels, it has a huge impact on greenhouse gas reductions. And I'm hoping to find out at some point in time throughout this process from the city what their overall plan is or their mandate is for reducing greenhouse gases. Many municipalities have a mandate to reduce greenhouse gases going forward, and solar thermal is one of the best ways of reducing those. The other thing with solar thermal is it doesn't require any upgrading of the electrical grid. As you may have read with the Green Energy Act and photovoltaic panels, the grid requires upgrades to allow photovoltaic systems to be online. Solar thermal systems are self-contained, and thus you don't have that problem. And on top of that, when you replace electric as a fuel source, replacing electric hot water heating, you also reduce the demand on the grid as well. The disadvantages of the solar thermal right now, if you've heard of the microfit or the FIT, solar thermal does not qualify for that program. Secondly, solar thermal requires some ongoing maintenance. After a number of years, you will have to check the fluid, change the fluid, etc., etc. And the other last one there is that it's difficult to produce electricity. There are some commercial systems that they're experimenting with that will produce electricity. Components of the system. So you have your solar collector panels. Okay, so the sun hits the panels. You have heat transfer fluid, which runs through piping up to those panels. A solar storage tank, a heat exchanger. In the case of a drain-back type of system, you have a drain-back type of tank. You have generally electronic controller to control the operation and function of the system. You have temperature sensors in the system that work in combination with that electronic controller. A hot water tank, you have a pump and a pumping station. anti-scald valves, safety valves, and then depending on the type of system, you may or may not have an expansion tank also. So the basics of it, you have solar panels that are mounted either on a rooftop or on a ground mount type system facing south. You have a piping which runs up to the solar collectors, and that contains the heat transfer fluid. And then in this particular system here, you see the rectangular box mounted on the left tank. That's actually the pumping station. So it contains the pump, heat exchanger, and a number of other components, and at the top of it actually has the electronic controller. So what that does is it takes the fluid from the collectors, goes through the heat exchanger, transfers the energy into this solar storage tank, where it's stored, so that's full of water. And then that solar storage tank in turn feeds your regular hot water heater. So these all act as a preheat type of system to your existing hot water heater. Now, because we can't get sun every single day of the year 100%, we can't have all of our energy solely come from the solar system. Generally speaking, the design of a solar domestic hot water system is to give you 50 to 60% of your hot water heating needs on an annual basis. And that's set up so that in the summertime, 100%. In the fall and in the spring, you get roughly 65 to 85%. And then in the wintertime, you drop down to about 20 to 25%. It's just a matter of how many days of sun basically that you get. In the wintertime, we just get a lot of clouds. Next slide, please. This is sort of showing the tanks in a little bit better detail, I guess. So, showing that the hot water coming out of the solar storage tank feeds into your existing water heater. So as soon as you turn a tap on, that water feeds through into your regular hot water tank. Cold water comes into this solar storage tank. At the top, you see a couple of bypass valves. So you can actually, if you were to shut those off, you can actually isolate your solar system entirely. If there's any type of issue or you're going to be maintenance on the system, you can isolate it from your existing hot water heater, so that you won't be without hot water if there's a problem ever with the system. Next slide, please. Types of systems, closed loop. So those systems that I showed you there are closed loop type of system, which means that it's a closed loop of the piping where the fluid flows from a pump up to the collectors, back down to the pump, and that's one closed loop. Then there's a drain down type of system, which is not very common anymore at all. And then the third one is a drain back. Next slide. So in a closed loop type of system, basically you have your pump there, which will pump the cold fluid up to the collectors when there's energy to be gained. There'll be a sensor up the collector to sense the temperature at the collector. There'll also be a sensor down at the bottom of the storage tank. And it works on a temperature differential. So when there's enough energy to be gained, the pump comes on, and the fluid flows up, and then goes through the heat exchanger, and that's the closed loop on the glycol side. That's what's referred to as the closed loop. On the other side, you have your water side. So you have your tank, and in this case, this is showing what's called a thermal siphon type of loop. And this actually works with natural convection of the fluid. So in this case, the cold water would flow up through the heat exchanger in the opposite direction to the heat transfer fluid. The hot water would just deposit itself into the top of the tank, and as you can see, the tank gets stratified so that when you're supplying your existing hot water heater, you're always pulling the hot water off of the top of the solar storage tank. Next slide, please. This is an example of a different type of, similar type of system. It's also a closed loop. However, this is not a thermal siphon type of system. Instead, this system has a pump, a circulator, which forces the flow through the entire system. And instead of having a heat exchanger and that thermal siphon loop, you have an internal coil in your solar storage tank. So this is basically what they call a forced system, so the flow is forced through this and then back up. This is another variation of this type of system, only in this case, what we have here is there's a heating unit here, and they're doing some space heating, and it's got a dual coil in this same tank. So it's a very similar type of operation. You can do radiant floor heating with this type of thing, or space heating. Next slide, please. The drain down system, you don't really see a whole lot anymore as far as the system goes, so I'm not going to spend a whole lot of time on it. Basically, with this type of system, you actually have your tank here, which is filled full of water, and then water is actually pumped up into the collectors, and water returns back down into this tank and will continue on as long as there's energy to be gained. Then what happens is, either in the case where there's no energy or there's freezing conditions, the water actually drains down and just goes to a drain. Okay? Commonly, the drain down is confused a lot of the time with the next system, which is the drain back system. So you don't see the drain down system much anymore at all. So the drain back system works in a similar type of way, but is much more improved than the drain down type. So with this type of system, what you basically have is you have this drain back tank here. And what you'll have here is, here's your pump. So when there's energy to be gained at the collectors, the pump turns on and the flow goes up to the collectors and then comes back to this drain back tank. And this drain back tank is open to atmosphere, so it's not a pressurized type of system. Okay? So the heat transfer with this type of system, there's several different methods. This one is actually showing an internal coil for the heat exchange on this type of system. You could have an external heat exchanger down here, which in that case you'd have a secondary pump which would pump the water from the tank, and it would heat exchange with the fluid from your drain back tank there. Several configurations with the heat exchange that you can use, and we'll get into that a bit later, with the type of tanks or the type of heat exchangers. I just sort of wanted to show you some of the main principles, I guess, behind the actual system, and I wouldn't get hung up too much on the different methods of heat exchange, because there's 2 or 3 types of heat exchange methods that you can use, but just to be aware of them. Okay, next slide, please. So that was the domestic hot water heating system that you use for either for your home, for your hot water, or in commercial applications. It's very, very similar, only more panels, bigger tanks, et cetera, et cetera. I wanted to touch a little bit about pool systems, because for many people who have pools, if you're using a gas heater on a pool, you're using more energy to heat that water in the pool than you are for heating your hot water at home, inside the house. So the pool system is a simpler type of system, consists of collector panels. You have either a manual diverter valve, or you can have an automatic control system, similar to a domestic hot water system, where it diverts the flow to the collectors when there's enough energy to be gained, and will bypass the collectors when there isn't enough energy to be gained. Generally speaking, it's plastic piping that's going up to the collectors. And if you have an electronic controller, you're going to need the temperature sensors, and it works on the same temperature differential as the domestic hot water heating system does. So with the pool, again, it's a little bit simpler. I don't have all the components actually shown in here, but you use your existing pump on the outside of the filter. Use your existing pump. Basically, the flow going up to the collectors is actually the diverter valve would actually go in here. Up to the collectors and then back down to the pool. These type of systems use what's called an unglazed type of panel. and they're approximately about a third of the cost of the glazed type of panel which you see over there. So there's no glass on it, there's no insulated sides, it's basically a plastic type of panel that just goes straight on the roof. And these type of collectors are used strictly only for summertime use. If you're going to heat an indoor pool in the wintertime, then you have to go and use the glazed type of panels. Next slide. So the type of panels that there are, basically there's either a flat plate, which you see over here, or a tube type of insulated panel. And they're either called vacuum tube or evacuated tube. It's the same thing, depending on the company, they interchange those words. Pool heating panels, as I showed you, are an unglazed panel and uninsulated. Next slide. So the flat plate are the simplest of all the solar types. It's a mature technology, and the system efficiency generally is about 70 to 80%. That's the approximate size of most of the panels that are out there, is a 4 foot by 8 foot. And each one of those panels will produce approximately 1,500 kilowatt hours for a 4 by 8 panel per year, and it varies slightly with the different manufacturers. Okay, this is a typical flat plate collector here. There's different configurations that they have amongst flat plate collectors. This particular one uses what's called a serpentine tube. So this is one continuous tube. It's a little difficult to see, I know, that runs all the way through the collector. There are other collectors which use header pipes top and bottom, and then they use parallel risers which go up through the collector. So a couple of different types, basically, of those type of collectors. Next slide, please. The evacuated tube collectors are a little more complex. Their efficiency is basically similar to the flat plate, and the approximate sizes, generally speaking, they add more tubes and then it becomes a wider type of panel. Again, they produce a similar type of energy a year. They are capable of producing some higher temperatures than flat plate collector, and for that reason sometimes they're used with process heating applications. So this is sort of a cutaway of the evacuated tube, where you have this glass tube. You have, basically it's like a mini little collector or absorber plate inside of each tube. You have two header pipes up here encased with insulation. Next slide, please. Now there's advantages and disadvantages to both of those type of panels. Depends on what camp you come from, whether you're selling, which panel you're selling basically. When I talk to a manufacturer that manufactures both and sells both, they'll tell you that they're about the same. And there's advantages of each one. For example, the vacuum tube, because it has the vacuum, it doesn't have the same heat loss as what you get with the flat plate type of collector. But then the other thing with an evacuated tube collector as well is if it's buried in snow, it won't melt the snow because it doesn't give off any heat. So, you know, depending on where you come from with that, there are advantages and disadvantages. Another advantage of the evacuated tube is you can mount it vertically on a wall, and then you can also turn the tubes to direct towards the sun. The flat plates are generally fixed on whatever angle that you're mounting, and there's generally no adjustment of the collector angle in that regard. Other components of the system, we've got heat transfer fluid. Water is actually the best heat transfer fluid, but generally speaking, a mixture of propylene glycol is used, or inhibited propylene glycol for freeze protection. Next slide. Types of piping. Rigid copper, rigid steel, soft copper tubing, corrugated copper, and corrugated stainless steel tubing. The corrugated stainless steel tubing is really nice stuff to work with, but it's also the most expensive to work with. Next slide. Internal piping, very similar. One thing that I do recommend to people is to avoid PEX piping. I've done testing when I worked in the research lab with different types of plastic piping, and basically everything mostly out there is designed for the temperature not to exceed boiling water. And solar systems will exceed the boiling point of water, so hence you don't really want to use the PEX piping other than for cold water piping. I know some manufacturers will say, you know, after 6 feet from the collectors or what have you, you can use it. I've done testing with it, and the fittings keep loosening off all the time with it because of the different rates of thermal expansion with metal versus plastic, and the things continuously leak and just tons of problems with plastic. Next slide. Types of solar storage tanks. Depending on your system, as I showed you the systems there, some systems use actually electric hot water tanks for a solar storage tank. If you don't have an internal coil heat exchanger and you're just looking for that for a reservoir, electric hot water tanks are the cheapest thing going. Internal coil type of heat exchange or multiple coils, as I showed you in the other system. And then there's another one which is called a tank-in-tank, which a little bit difficult to describe, but it has literally it's a tank inside of a tank, and it uses the outer shell of the inner tank as its surface for its heat exchange to the fluid in the outer tank. Next slide. Heat exchangers. So external to a tank, you would have a flat plate, which is very common type of heat exchanger. Very good heat transfer with a flat plate heat exchanger. You also see shell and tube. They're not as common. They're a little more expensive, and you don't get the same heat transfer. However, they're used in many industrial applications, like in injection molding machines, for example. They're used as a cooling mechanism. Internal tank heat exchanger coil. They can be glass, ceramic, or enamel coated steel, or they could be a stainless steel. The higher quality ones are a stainless steel type of coil. And then also I put up here the tank and tank because it's both a tank and it's also a heat exchanger, really in effect. It does both those functions. Types of drain back tanks. You have a standard type of tank, which would be much like your just an open vessel. And then in the one system that I showed you there, they had an internal coil, which is probably not quite as common. So the electronic controller, pretty much every system has an electronic controller, and it controls the whole functioning of a system. There's many brands available. Many manufacturers get their own custom one made for themselves. Several brands that are common. Resol is one of the most common ones that's made in Europe, and they actually do private branding for many of the other manufacturers as well. There's also a company based out in BC, Techmart, and they do a lot of good quality products as well in terms of controllers. So the controller works in combination with these temperature sensors. So basically you have at least 2 sensors in most systems. You're going to have more sensors in systems where you have more functions going on, where you have multiple storage tanks, etc., etc. So the basics are you have a sensor up to the collector and a sensor at the storage tank to measure that temperature differential, which feeds into that electronic controller and tells the electronic controller. The electronic controller is usually pre-programmed at the factory, and we'll turn the system on and shut the system off based on a temperature differential when there is or there isn't energy to be gained. Hot water tank. So the hot water tank is part of your system still. So when people say, "Can I replace my hot water heater?" No, you can't entirely. It is possible under only very seldom conditions. If you're, for example, if you had a cottage and you're just going there on the weekends, perhaps in the summertime, you may be able to get sufficient enough solar energy just to run pure solar in the summertime. You could do that. That's sort of an exception to the case. Top feed tanks versus bottom feed, just a different type of tank. Higher quality, some of the higher quality tanks will use a stainless steel liner inside instead of a glass coated or ceramic coated steel. And some of the stainless steel tanks inside have lifetime warranties on them. You have your pumping station, which contains your pump. There's different types of pumps. Commonly, the circulator pumps, which are used in the force type of systems, are Grundfos, Taco, and a Welo type of pump. There's also a gear pump. It is possible to have entirely a PV powered DC type of pump as well. The pumping station is usually unique to a manufacturer, although there are some sort of generic ones like PAW is a German company, and you can sort of fabricate your own system if you really want to by taking that pumping station, if you know what you're doing, taking someone's collectors, taking someone's tank, and putting a system together. I just want to touch a little bit about the anti-scald valve. Anytime a hot water heating system is changed now, you have to, by law, put an anti-scald valve on. And a very good idea anyway to have one on, because there's a huge number of people still getting burnt by hot water overall. So a true anti-scald valve will prevent that, and it goes on the outlet of your existing hot water tank. But if you get a solar thermal system put in, you have to have one of those put in if you don't have one already. There's different types. Some that are referred to as tempering valves, thermostatic mixing valves. You want to make sure you get the true anti-scald valve. They're usually a little bit more expensive than some of the lower priced tempering valves. So you need to be a bit careful there with that type of thing. But a true anti-scald valve covers you under several conditions to prevent anything like that happening. So to prevent problems in your system, there are some safety valves because you can't compress fluids like you can compress air. So when they expand, they have to have somewhere to go, or something's going to blow up or break or what have you. So commonly there's what's called PRV in the industry, commonly referred to, which is your pressure relief valve, which is a safety valve. So if it goes off, it's going off for a reason, and it's going off for your protection so something doesn't blow up. The second type is called pressure and temperature relief valve, so it works on both of those items, not just the actual pressure in the system. So again, if you exceed a certain temperature, it will activate as well. Generally speaking, you have one always located on your hot water tank, and then you also have one located on your solar storage tank. And you have one also in a pressurized closed loop type of system in your heat transfer loop as well. There would be a pressure relief valve in that system. All safety devices. Depending on the system that you have, in a closed loop type of system, you have an expansion tank on the glycol side. And this is actually a bit of a safety device in itself. So what it does is it allows for the expansion of fluid in the system as things heat up, and especially it's activated when you've maxed out your solar storage tank. It's, let's say, 2:30, 3 o'clock in the afternoon. Your collectors are still sitting out there in the sun baking away, and all that fluid in there is getting hotter and hotter and hotter and hotter. So it starts to boil out of your collectors, and it needs somewhere to go. And you don't really want it blowing off your relief valve. So an expansion tank is put in the system as a safety device to absorb that fluid. Also, it can be on the cold water supply, so that if you have a backflow preventer, if you put a backflow preventer in your system, many municipalities, it's law that you have to have one on your cold water supply, and that's for the integrity of our water system. Once you do that, then you've created a situation where the water is stopped in your piping, and if it expands, again, it has nowhere to go, and it would just burst your pipes. So you'd have an expansion tank on the actual water side of your system. The tanks are rather similar in nature, both of the tanks in their whole design, pretty much the same. The one thing is it does need to be sized properly for your volume of fluid. Safety issues. Collectors heat up and they get hot, obviously, and regular flat plate collectors will get up to 300 to 400 degrees Fahrenheit. So if you're working on one of these solar systems or what have you, it's not advisable to touch anything at the top of the collector unless the collector is covered, but they will get very hot. The heat transfer fluid can get up to 230 degrees Fahrenheit, so it will burn you. And all the components that are contained in the pumping station or the piping or any of those fittings, any of the metal fittings will also get hot and can burn you. It says right there, show. The water in the solar storage tank can reach temperatures of 170 degrees Fahrenheit, and that will depend sometimes on the manufacturers, how hot they set the temperature, and you can generally adjust that temperature as an installer. The goal always is, if you go back to that illustration of the solar storage tank, the goal always is to have the water at the top of the tank as hot as you possibly can without having problems of the relief valve discharging, without the water reaching the boiling point, essentially. The water in a regular hot water tank, the tank is usually set to 140 degrees Fahrenheit, and the reason for that is to ensure that you kill Legionella bacteria. So if anybody's ever heard of Legionella being a problem, I heard of a guy in the States, and he kept saying to me he was having problems with his system. He's turned his burner off. I couldn't understand what he was talking about, but eventually he told me he had a propane hot water heater, and it was summertime, so he just turned it off. And I said, well, okay. I said, you know what risks you're running, don't you? I said, I mean, if you get enough sun where you can keep the water temperature hot enough in your solar storage tank, you're fine. But if you have 3 or 4 or 5 cloudy days and you use a bunch of water and that temperature drops down in your solar storage tank and you don't have a hot water heater to bring that temperature up, it won't kill those bacteria. So you might be having an expensive trip to the hospital, and so it sort of clicked in, I think. But I said, that's your choice. I'm just telling you, there's no actual bypass, and you could put a bypass in to bypass your hot water tank. But generally, it feeds your hot water tank as a preheat. And as I said, the only real condition that's an exception is if you have a cottage and you're just using it on the weekend, and the system sits there for 5 days and heats up, so by the time you get there, it's all nice and hot, and you're not using much water in 2 days. And the last thing I guess I said is that water doesn't compress like air, so it's got to go somewhere. And that's the end.